Hey everybody, it's Erik Torenberg, co-founder, partner of Village Global, a network-driven venture firm. And this is Venture Stories, a podcast covering topics relating to tech and business with world-leading experts. Hey everybody, great to see you all. We're very lucky to have very special guest, Ash Fontana, joining us today. Ash, welcome.
Thank you for having me again.
Absolutely. Ash, for those who may not be familiar, is a partner at Zetta, co-founder of Zetta, which is a venture capital firm that focuses on AI-driven companies, has just released a book, author of the AI First Company, and has been a long-time friend and collaborator to Village. So excited to get into this conversation, Ash.
They're always fun. We've gone in lots of different directions in the past, and this is yet another one.
Exactly. And we've released a few Venture Stories podcasts before for people who might want to check those out. They're quite good. Ash, well, first off, congrats on the book. Let's start with that as an intro. What compelled you to write this book? And what is sort of why don't you give a bit background for those who may be unfamiliar?
Yeah, good question. So my background is that at the moment, at least, and for the last decade or so, is as someone who is completely focused on trying to understand this new tool that is artificial intelligence. Lots of terms for it, but that'll do for now. And I do that by backing and helping companies. And I learn a lot about that from the founders I work for. But obviously I read around and read a lot of papers and whatever else, and just learn about that as much as I possibly can, because I believe it's such an important tool. So that's what I'm all about. And, before that, I've just been investing for a long time and helped get AngelList off the ground and started a company and did a few other things. But why write a book? It's a great question, when you can just write a couple of tweets, it seems, and get all the attention you need. I wrote a book because I'd accumulated this knowledge about how to bring some of these technologies into the real world. Again, mostly by learning from the founders I work for. And no one had sort of accumulated, consolidated, and shared that knowledge. And so it's things like, how do you face the challenge of customers who are not quite sure about how to work with their data rights in the contracts you're signing with them? Or how do you pitch the value of a prediction as opposed to a product? Or how do you manage a team that's sort of half machine learning research and half software engineering? There are all these unique challenges about starting these sorts of companies that I've been facing for almost a decade now, and learned a little bit about how to solve them. And so I just had all this knowledge, and I view sharing knowledge as a moral good. And so I thought, well, let's get it out there. So that's the first reason. The second reason sort of goes to my tongue-in-cheek comment about tweeting, which is it's sort of the case that if you publish something like this sort of knowledge in a series of blog posts, people's attention is so limited. And, on the one hand, it's a little bit dissatisfying as an author to put so much effort into something and then see it sort of get into the consciousness and disappear from it all in the same breath. But more so, I don't think it's what readers actually want if they truly try to learn something, as in, having a series of blog posts that sort of reference each other and then reference a bunch of external things creates a huge burden for people trying to accumulate knowledge. They have to jump around and fill in a lot of gaps. Whereas if you just have a book that has its own set of terms in a glossary, a way to navigate it that people understand, like a table of contents and an index, and is a standalone thing, as in it's self-referential, has all the material you need to fully understand the concept in one place, it's much easier to learn something that way. So that was the second reason. And thirdly, I just love writing. And so if I could find a way to turn my hobby into something that was useful for at least a couple of people out there, then I was going to try and pursue it at some point. So there's some of the reasons why I decided to write this thing.
Awesome. Well, I want to get into some of the meat there. Let's continue setting the table here. What is an AI first company? What is the most concise way you think about framing it?
Yeah, the most concise way is an annoyingly recursive way, and that is an AI first company is a company that puts AI first.
Yeah.
But really, this is part of the reason I wrote the book. People are starting to understand the imperative to care about AI. They're reading about it so much and hearing just how powerful it is, but they don't really know how to sort of bring that into their day to day, whether they're a line manager at a company that wants to get a promotion, whether they're someone running a family business or whether they're starting a company, a startup or otherwise. People don't really know how to bring it into practice. And this is why I called it the AI first company, because I wanted to create this imperative to put AI first. And what does that mean? It means putting it first when you're having your initial conversations about what's the next product we're going to build, who's the next person we're going to hire, what's our policy for X. It's how you price products. Every conversation you have at a business every day can have an angle on it, which helps you ultimately develop a company with this really powerful competitive advantage that AI gives you. And this book hopefully teaches people how to have those conversations, gives them the vocabulary to have those conversations, etc. And so to wrap up, that's what an AI first company is. It's a company that puts the considerations around AI. How do you get data? How do you feed it into predictive models? And how do you develop a system that automatically gets better over time? It's a company that puts those considerations into the conversation early so that they can ultimately build a real AI system that develops a competitive advantage for themselves rather than just try to sprinkle it on later.
Yeah, it's interesting. You talk about how every company needs to prioritize AI over the next decade. I'm curious for you to unpack that for the group. But then also it is interesting. I don't know if this is attention or necessarily related, but it seems that there was this critique of, I don't know, YC companies a few years ago where every company was calling themselves an AI company. And in fact, not all of them were.
So I guess what I'll say has changed from my perspective as someone who has been investing in this field for quite a long time now. Zetta was the first fund completely focused on this, is that there has been a change in sort of how people pitch things. Initially when I was meeting companies and looking to back them through Zetta particularly, and I was obviously backing companies for a decade before that, but lots of different types of companies, you would mostly meet machine learning researchers who were building everything from hand. And when you met them, they would explain to you what they built by hand, as in what models they built, what research they'd done, and how they would maybe bring it into the real world. And so it was the case that they had to do that. And that was a big part of their pitch, and a huge amount of the defensibility was in the models there. What is the case now is that people have access to a lot better tools, still not good enough. There's still so much more to build there. And people sort of assume more knowledge about machine learning, that when you're sort of on the receiving end of a pitch for a new idea or a new business, people are sort of jumping straight to or making assumptions about, okay, all of this stuff works and here's how I'm going to apply it. And as someone on the receiving end, it's a little bit more difficult to sort of distill, okay, that's good. You've probably got a good business here, but do you have something here that is going to get defensibility from the models you built? Or do you have something here that's going to get defensibility from the data you have, or just the application you're building on top of these sort of models that you're getting from elsewhere? So that's, I guess, the challenge now is sort of working out where we are on that spectrum with any given person who's sort of trying to get funding for a business. And that's a good thing because, more people have access to more ways to get started with AI. And there's not less machine learning research going on now. There's not less good work being done. It's just that you've got to distinguish between the people that are applying this stuff, that's maybe something that's a relative commodity model, so to speak, or people that are really trying to innovate on sort of core AI systems. And both are valuable.
What is the difference between, or unpack the difference between lean startup and lean AI?
The lean startup concept is phenomenal, right? And for those who haven't picked up the book in a while or never picked it up, it's really about sort of trying to get to a couple of questions that help you figure out if the features of the products you want to build are really wanted by customers. And usually it's the software product you're talking about there. Lean AI is more about whether the features of the prediction you want to make for someone are actually predictive and whether that prediction is going to help them in their business. And it's sort of quite a different process, but it's with the same goal. And the goal is, I have a hypothesis about what I think will be valuable. I think it'd be really valuable for people to know this thing ahead of time. I think it'd be really valuable to automate this process. And I've got 100 different ways of doing that, but here's the one experiment I'm going to run first. And so Lean AI is all about, what experiment I'm going to run. What's the one data set I need to run that experiment? Not what are the 20 data sets I need to clean up, put in the one place, consolidate, whatever. What's the one data set I can run it on? What's the one model I can try? And not some series of complicated machine learning models. What's the one statistical method I can use? What's the one output I'm going to have? It's one chart or one report or one Excel sheet. It's not some sort of complicated product that allows you to interact with the model in some way. And where do I think I'm going to end up? And once you've got that, then you can go, all right, I've made this prediction with this level of accuracy, but it needs to probably be a bit higher for a customer to rely on it, for example. And what am I going to do to get there? Am I going to get more data? I'm going to change the way I'm modeling this problem. Do I need a different person to bring in to help me model this problem differently? Do I need to get like a data science consultant or something? That's what Lean AI is all about. So it's a very similar process in that it's a way to just sort of narrow down. It's a series of questions to ask. It's an actual framework to use to narrow down what you want to test. And it's very similar in that after doing that test, you know where to invest next. But it's very different because we're not talking about a product here. We're talking about a prediction. And we're not necessarily talking about starting a whole company. We're talking about providing a huge amount of value with one model, for example.
And what are common mistakes founders make when running a sort of lean AI process? Is it that they think that they have something predictive and it's not, and they just mistake that, or is that they wait too long or until they have conviction, or what's a common mistake to watch out for?
Yeah, it's really basic stuff. It's sort of, in a sense, goes back to high school experimental method stuff that you learn in science class. Like, just be really honest about what you're trying to predict and what your hypotheses are and what your method is. And, make sure, for example, with machine learning, you have a set of data on which you train the model and a set of data on which you compare the results, the holdout. So there's basic experimental method stuff. I think a lot of the pitfalls, and the Lean AI chapter goes into that. It's got a lot of like do's and don'ts, very straightforward stuff. A lot of the pitfalls are around the data that you think you need. And a lot of people spend so much time gathering and organizing and labeling data just to run an experiment that they probably could have run on a smaller data set and sort of found the same thing. So I think that's certainly a big pitfall for people, is in the data gathering and organizing phase. And I think finally, it's just sort of an overcomplication of method, not just means. And method meaning, people try to often throw a lot of data at an off-the-shelf machine learning model. But really, if you want to understand the cause of something, like what's the fertile variable, what's the thing that really causes this other thing to happen, often you can just do that with like a very simple statistical model. And it's not as powerful. Maybe the output might not be as interesting, I guess, but at least knowing one cause of something can help you figure out the next cause of something. Like, you want to find like the main cause first to get to 80 for the 20. And then you can start looking for other causes and other influences on an output, I guess. Yeah.
And how about even zooming out a bit in terms of coming up with the predictions in the first place, or knowing what's your advice for that?
Yeah, this is just all about knowing your domain, right? So, this is why a lot of the teams that we work for are made up of one person with a lot of experience in the domain and one person with a lot of experience in machine learning. This is all about knowing your domain. It's all about knowing, look, I've worked in the restaurant industry forever, and I know that the most important bit of inventory for me, the one that where I waste the most amount of money by getting it wrong, is perishable food. It's like meat. And I know that the biggest predictor of whether or not I will use all the meat in my fridge or not is this. And I know that if I just can figure out a better way to reuse stuff by recombining menu items, then I'll waste less. Or, and you don't know that unless you've been a chef, like ticking off stock in the cool room at 2 a.m. after your shift. So it's having the domain expertise. Like it's a learned thing. It's a heuristic, and that's where you got to start. It's very rarely the case. Sure, sometimes that you throw a bunch of data in an unsupervised model and it tells you the cause of something. It's more often the case the cause of something is known by someone with a lot of experience. Then you can go into a lot of examples around drug hunting, for example. Finding new drugs, drug discovery. People have been so excited about using machine learning to do that. The reality is, if you have no understanding of the underlying biology, your solution space is absolutely huge, so to speak. And so using machine learning to traverse the space of all possible drug combinations in the world for some condition will probably take a very, 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 very long time. But if you just start with some knowledge of the actual biology of the system, and you can code in some of the mechanics, the liver works like this. When this compound gets into the liver, it processes this way. You get 80% of the way there, and then you can use machine learning along the way to make it better.
Yeah. And I'm curious, when you look at this from a VC perspective, and you're looking at a company or companies in the drug development space, let's say, so you're not your domain, are you just sort of trusting their domain expertise, or how do you sort of get comfortable with sort of product market fit, or even before they have a product, I guess. But how do you look at these companies as an AI investor when you don't have underlying domain expertise in all of these categories?
Yeah, it's sort of obvious in the results. And so, we try to get involved at a point where I say it's sort of pre-traction, but post data. So it's the point where, you don't have customers yet. You don't have any sort of revenue or anything like that. But what you do have is an experiment that you've run, maybe just one experiment. And you may have made a prediction about something. I can predict, how much meat you'll use this month, going back to that restaurant example. And you then check it off at the end of the month. And did you waste more or less than last month when you didn't use this model to make that prediction, to make your purchasing decisions? You can see how good it is. So, as an investor, all I need to really know how to do is analyze an experiment. Now, that's sort of easy in a way. You can look at the results, but it's sort of hard to then figure out the next thing, which is, okay, based on the results of this experiment, what are we going to do next? Are we going to allocate more capital, really everyone's capital allocator, whether you're an investor or CEO or otherwise, to buying more data, to hiring a certain person, or something else? Like, what are we going to do here to make this thing more accurate? Or to make this thing, more importantly, accurate enough. And so that's what we do. We don't need to know the underlying causes of things. We don't need to be the expert in any one domain. We just need to help people figure out where to allocate capital best to make these things better.
And are there common mistakes that you see them misallocating capital towards, XYZ, but really it should be ABC? Or how are you typically coaching founders through that process?
Oh, that's a hard one because it's so idiosyncratic, of course. But yeah, I think a lot of people early on probably, it depends on the business, but they probably allocate a bit too much capital to marketing, I guess, in a lot of AI first companies, when, really you've got to probably allocate a bit more to sales. A lot of the process early on represents, what we used to call in the software industry, like working with a design partner. And that in the past was, if you're building this big, massive enterprise software product with a heap of features, back in the day where building software was super expensive, you worked with a partner early on to sort of be the first customer and tell you what features to build and whatever. This was before the lean startup idea and before it was so cheap to just spin up a bit of software. So that was, something that people used to do. And that's a concept that's really relevant to an AI first company, because you can work with customers to get one data set to run a prediction just for them, and then later generalize it to other customers in their same industry. And that's a sales process. That's a business development and sales process. And so I think early on, people probably think that the model they've developed is really broadly applicable and accurate enough and usable and whatnot. And, usually one of those things is not quite right yet. And so you have to work with the customer, one or two customers really closely that have really good data, but not so much machine learning expertise, to get that right. So getting that right and allocating money to sales and business development first to get those initial data sets and deals. And so the models get working, and then you have this sort of flywheel going, is really important and probably underdone there. I think in some cases, allocating money to machine learning research early on is probably not necessary, but in other cases, it's super necessary. So it sort of depends. I guess what I don't see is a misallocation to spending money on data. I think what I see a lot of people be super creative about getting the data they need, which is awesome, because, that can be a really expensive and fraught process. That is, acquiring data from third-party vendors and whatnot. It can be fraught. There are a lot of weird ways people collect and sell data out there. And I've seen most startups be really creative and also just like work really closely with their customers to do that, which is good.
Yeah. And how about putting the VC hat back on in terms of, so you mentioned sort of the stage that you like to invest. How about in terms of evaluating markets, in terms of, some markets could benefit more or less from, more sort of AI or not, or crowded versus not? How are you sort of thinking about what markets you're particularly excited for your particular lens to invest in and find companies in?
Yeah, I guess something sort of orthogonal to that is I'm at this point in time, and look, it's changed over time based on how these things have been accepted and adopted by certain industries, and also based on what the big tech companies were doing. But I'm really focused at the moment on machine learning tools and infrastructure. So that is things that make the job of a data scientist or a machine learning engineer easier, better, etc. Whether it's tools to manage different versions of models or train models or monitor them, whether it's ways to deploy them more easily, ways to just automatically manage data cleaning, data labeling, data synthesis, stuff like that. So I'm completely focused on that for now. Now, that's not industry specific. There are data scientists and machine learning engineers working across industries at big industrial companies, healthcare companies, whatever, that all need these tools. So that's my focus. But to answer your question, what areas am I really excited about? In a general sense, it's areas where our human knowledge is very limited. So our human knowledge of how a system works is really limited. So for example, a biological system, an environmental system, etc. These like very complex systems that have mechanisms at play that we just don't really get. Like we don't really know how wildfire spreads, or we don't really know how the liver does a lot of the amazing things it does. I'm obsessed with the liver and the brain. They're two of the most complex organs there. And you can throw machine learning models and more broadly intelligent systems like agent-based simulations and whatever else into these environments, and they find things out that are really remarkable. And what they find out or what they predict might not actually be useful, but if you dig into how they made that prediction, it could be really useful. And, I hate to be the 4,000th person to mention AlphaGo on a podcast about AI, but if you look at some of the moves there, they in and of themselves might not have led to a victory, but they were really weird, and studying those moves helped us learn a lot about potential strategies there. And, for example, there was a model recently that finally was better than some of our existing models at weather prediction. And, I'm pretty skeptical as to whether that model will be consistently better at weather prediction. but learning how it figured out the weather ahead of time in a way that's totally different from how we model weather today actually can inform our current models. So anyway, I'm excited about those areas. I've sort of incidentally mentioned some of those areas in talking about this. So some things like understanding like discrete environments in our natural world. So understanding fires, understanding water flows through certain systems, understanding better ways to store water, move water around, electricity, understanding our electricity grid is a problem I've spent a lot of time on in the machine learning world, or with people in the machine learning world. Those sorts of things I'm really excited about. And even things like understanding the behavior of actors in financial markets to make our financial markets more efficient. They're pretty inefficient in so many ways now, in terms of like trading fees and the structure of certain exchanges and things like that. So understanding those systems is what I'm really excited about. And really what it comes down to is AI getting involved in knowledge creation, not just automation.
That's actually a great segue. We have a question from the audience. I'd like to bring up Ben to ask it.
Hey, Ash, thanks so much for doing this. How do you think about AI and venture capital? There are clearly some firms that done quite a bit of marketing about how they're using AI to be better investors. What do you think's overrated about AI and investing, and where might there be potential?
Good question. And so it's funny because at AngelList, we ostensibly had all the best data on startups. We had all this structured data about who was moving and going to what startup, what traction they had and whatever. And so we had a lot of people approach us, say, hey, I've got this amazing idea for predicting the success of a startup, or what's going to be a good investment. And I just need your data to work with to just sort of round it out or train this model I've got. And so I got to speak to so many people and talk about their ideas for how to predict a good investment or predict startup success more generally. I saw a lot of approaches there. And, frankly, the only one that ended up working very well was completely based on the quality of the investor. And it's basically like putting social proof in a machine learning model. So that's sort of an interesting tidbit. That's what worked for us at AngelList. We had like a quality score we developed, and that's what worked for a fund that was involved in AngelList. And that's what
that doesn't apply to us as much because we're totally independent thinkers, but I can see other firms that would rely on signal.
We're all completely independent thinkers. We're not social beings whatsoever. So that's all that really worked. Now, where do I use AI today to help find companies? Like what has Zetta done there? We use it to help us figure out where to spend our time. And so what we do is we essentially track who we think are all the most accomplished or promising machine learning researchers or practitioners in the world. And we figure out when they start collaborating with each other and when they start showing signs of wanting to start a company. And then we start talking to them. And now from there, it's all human. It's all about us talking to them.
So just to clarify, that's kind of meta. So you're using AI to research AI researchers who might be starting companies? Did I hear that right?
And when I say using AI, it's pretty basic stuff. It's just consolidating data sets and tracking how networks move around, or how when people start collaborating in a network. So that's what we do. And I think that's about as far as it can go, right? Because if you think about it, the space of possible companies that could be created in the world is so huge. And the number of people starting those companies is so massive that applying some model to all of that is really hard, because they're all starting totally different companies in totally different parts of the world. And there's different data available about each of them. Some people use LinkedIn, some people don't. Some people collaborate and talk on Twitter. Some people just don't use Twitter and use GitHub for their contributions to the world. Everyone's contribution is different, blah, blah, blah. So what we've done is, one, constrain the space. Like we picked those, call it 10,000 people. I think that's really important. And, if anyone's sort of trying to do more than that, it could be really difficult. I think what was also really important is recognizing what it can do. It can help you figure out some pretty basic signals. But figuring the notion of a good company, I mean, if we knew that, if you could code that into a model, you'd already be the best investor in the world and probably wouldn't be bothered building models.
Just one final clarification. I'll pass it back over to Erik and other questions.
Yeah.
But just Ash, you mentioned it's a really basic form of AI. Maybe a dumb question, but when would we use the phrase "we're using AI to accomplish a task" versus "we're using software, we're using a simple algorithm"? Like, we do a lot with software and data at Village. How do we know whether we're using AI or just basic web apps and APIs and the like? How do you define it?
Good question. I define AI as a form of a few things, a form of intelligence that we don't have. And so you're using AI when you discover something through it that you couldn't figure out yourself. I also define AI, or intelligence, I should say, something that learns really quickly. And so you're using it when it's learning at a pace that is quicker than you can learn. It's figuring out when one founder teams up with another founder to start a company before you can sort of execute that in a normal software workflow. Basically, if it's like if the machine learning model spits out a prediction you can use quicker than your Zapier workflow, it's probably AI. Because the Zapier workflow is definitely not AI, right? That's just a series of calculations, I guess, in a sequence. And so it's AI when it helps you, I guess, see around the corner a bit more quickly.
Awesome. Thanks, Ben. One of the things you talk about in the book is you mentioned the concept of loops. And you say that instead of moats, better captures the compounding competitive advantage of AI first companies. Can you unpack that a bit?
Yeah, for sure. I think, we've often used this word, a moat, a competitive moat, to describe the degree of defensibility of a business. And that's a nice, cute term because, we can think about castles and medieval stuff. And it does apply really well to, something like a patent on a drug, because it's a set period of time, it's 20 years or whatever it is, and no one can get on your territory for 20 years. Okay, great. But it's very static. And the reality about a lot of AI first companies is, one, a lot of what they build isn't patentable. It's either, built on top of stuff that's already in the public domain, models that other companies have already released or have been in a research paper or something like that. It's based really on the data that you've got, and you can't patent data. Data is just, a one or a zero in a way. So a lot of the reality of AI companies, or the reality is, you can't really patent much. You can't use a lot of those traditional ways to get defensibility that give you a fixed moat. So that's in sort of a negative sense. In a constructive sense, it's much better to think about loops, because two things are happening when you've got a model that's working really well. One, it's operating in a way where every time you run it, something changes. So you run it, you make a prediction, and people go, yes, no, that prediction was right. Yes, I do have more stuff on the shelves this month, and you said I would because I purchased too much. Or no, actually, I ended up with less. Or yes, there's a cat in this image, or no. So every time it runs, something changes, it gets more feedback. And so it's changing, usually positively, if the feedback you're getting on the model is good and right every time you run it. And two, if that feedback is good and right, it's getting stronger. The prediction is getting better. So the moat is increasing, as in, if someone else doesn't have this predictive model that's getting better with every run of the loop, they're further behind you. They're going to need a lot more data or time or whatnot to catch up to that degree of accuracy. So that's why loops are better for AI first companies. One, because a lot of the ways to protect intellectual property and whatever else are not really available to the AI first companies, just as they're not really available to a lot of software companies these days. And two, they operate in this looping motion, and they get better and better over time.
I want to talk about some of the elements of building a company that are sort of unique to AI first companies, or ask you how they're unique. How about, let's start with attracting talent and recruiting. What's sort of distinct about building an AI first company in terms of what you want to do there?
Yeah, I think the first thing is the roles are totally different. And there's a lot of nuance here that I guess is not really appreciated by many companies at this point. And I'm trying to help people appreciate, if they really want to build an AI first company. And that is, there's a big difference between a product manager and a data product manager, or a project manager and a data project manager, and software engineer and a data engineer. So a lot of these roles are differenced in nuanced ways. I'll just pick one of them. A product manager at a normal software company who really is responsible for consolidating the needs of customers, understanding usage patterns and whatever else, and figuring out what features to build into the next version of a product. A data product manager is really focuses less on the features that a customer clicks on and uses, and more about how do we make the prediction that they're getting better? Do we have to get more data from them, like add another button that gets more feedback data from them? Do we have to go and get this other data set from somewhere else? Do I have to form a partnership to get data from someone to make this model better? What do I have to do? Do we have to change the way I'm modeling this thing? The data product manager is a very different role than a product manager. So the roles are different. Two, the way you distribute those roles are sort of different as well. Often the technology function, and this is in bigger companies, obviously in startups, it's all one and the same. But the technology function is sort of fairly centralized. It's like, hey guys, we need you to build this software, go and build it. We need you to fix this thing, go and fix it. And that doesn't work that well for AI first companies because of what you asked about before, which is you need domain expertise to even know how to make a prediction. And you get that domain expertise into the heads of the data scientists and the machine learning engineers if they're out, if they're decentralized, if they're in the field, if they're out there with the people with clipboards who are doing safety checks or who are ticking off inventory on a shelf or who are doing whatever. Once they see them do that job, they can go, this is how I can automate it. This is the data I'm getting. This is what they're trying to figure out. And this is how I can automate it. So two, it tends to be the case for AI first companies that decentralization of technical expertise, data science and machine learning expertise is better. And the third thing that's quite different is how you attract talent, which sort of gets to the point of your question. And I guess I've got a couple of things to say there. I'll keep it brief, and maybe if we want, we can go into these areas separately. One, you find people in lots of different places. It's not just about hiring all the computer science graduates out of Stanford. It's about hiring the geology graduate out of a university that happens to be really good at geology because you do a lot of statistics in geology. Or it's about hiring the biostatistics graduate because they're going to be very good at working with the machine learning models because a lot of it is just statistics. So you actually can hire from a much broader pool of talent, so to speak. And then secondly, you attract people a bit differently. It's not just about, we've got this super fast organization, like software organization that works fast and works on really hard technical problems. It's about, we've actually got a lot of data to work with to model this problem. So you actually have a chance at solving it. That's what machine learning engineers are attracted to. They're attracted to environments where they can actually solve the problems they're trying to solve because they have the data they need. So whether it's having a huge amount of data because they want to work on image recognition problems at Google, or whether it's having a very specific data set because they want to work on, a medical prediction problem, like a drug discovery problem at a pharma company. So that's another difference.
That makes sense. How about in terms of AI companies thinking about retaining first mover advantage? How do they make sure they're not the MySpace of the category?
Yeah, it's funny. I think AI first companies have a real strength here in that if you do move first, you have quite a significant first mover advantage. I mean, first mover advantage has been criticized in, the management literature, the business strategy literature for a while as not really being a thing. And I think in the software world, we don't need to read all those papers. We know it's not really a thing in a lot of domains. But I do really think it's a thing with AI first companies because you have this combination of getting an initial data set that's bigger than anyone else's, using that to train a model. And then once the model's in production, you get this flywheel going where if it's generating an accurate prediction, people use it more. They're like, I want that prediction. I want to know ahead of time what people are going to buy, what clothes people are going to be into in 3 months. I want to know, how quickly I can deliver this product to consumers because then I can create an amazing experience for them by letting them know exactly when they're going to get their delivery. I want to be able to make these predictions. And then once it's working, then you get it out in the world and customers love it. And then you get more data by it just being out in the world, because then you get all the corrections and you can tweak it and whatever else based on how it's working. And so you have the combination of the data and then the feedback data that gets you much further ahead really quickly. And, this isn't theory, right? This first mover advantage thing. Like, Google was the first to use the sort of search engine that it built. There were other search engines, but they operated very differently. And it worked really well. And they trained it on an initial data set. And then it worked really well. So more people started using it, and no one can catch up. And this is like almost 30 years later, no one can catch up. Their first mover advantage is still real. And, Amazon, while it wasn't initially an AI first company like Google is, I would say that Google's the first AI first company, as an aside, it did very quickly realize the power of it. And it spun up this division called A9 to do like search and recommendations. And it became so good at that. It already had a bit of an existing customer base, so it could run all these tests and gather all this data on customer preferences. It had a really good team building unique models, and then it could run the searches and get feedback. Like, if someone searches for this, and we present these results, and they click on them, that's a good search result. So let's like boost that a bit. Next time we put the search results out for someone who searches those terms, it got better and better. And so now, like, more than half of the searches for a product start on Amazon. They don't start on Google. And that to sort of go against the first thing I said, there is one way in which Google's no longer the winner for product searches. So it's the case that there is this really huge first mover advantage for AI first companies in a way that's sort of not really there for software anymore.
Right. To your point that Google is the first AI company in your first company in your view. What are some others? How do we think about sort of the landscape of big AI first companies that exist today?
So sticking with big companies for a second, it's funny. I think Google's the only one. It's the only one that was all about AI from the start, was super strategic in how it collected data. Like, Google gave away so many products for free explicitly. Now, very upfront about this, to collect data, to make other things better, to make their search engine better, to make ad serving better, to make their self-driving car system better, whatever else. They did so much that was so strategic to collect all that data. And the evidence is there. Like, they just have this unassailable lead, and it's $1 trillion company. So Google's the first of the big tech companies, the only one. Amazon, as I said, sort of halfway through realized this. Well, a bit less than halfway through now. And so they started a business that did one thing and then very quickly built AI to improve its core business, whether it's on the factory side or on the consumer experience side. Microsoft are funny because they did a heap of research into AI. They've done a lot of the groundbreaking research in AI, but they didn't really make it a core part of their business. Word, maybe Clippy, but Word and Excel and whatever else don't really have AI built into them. They build AI now. But Amazon have sort of released some of those products as services for other people to build AI, which is cool. But they're not, I guess, an AI first company, I would say, or have taken a while. They sort of are now. They're the big companies. Really, a lot of their companies people think of as AI companies that are like big startups now, like Palantir and UiPath. I would argue they're not AI first companies because, at least for the longest time, UiPath does a little bit now, Amazon does now, Palantir does now, but they don't really use AI as a core part of their product. They really build platforms to let other people use and build AIs. So they're sort of more platform technologies, I guess. The AI first companies are still the ones getting built. We're really just at the crucial point, the pivotal point, I would say, in this AI first century, in that a lot of the startups now are being built from the ground up to use AI. So, a lot of the companies you've backed, like Verisim and whatnot, some of the companies we've backed, like Tractable and Lilt and Focal, these companies from day one were very strategic about collecting data. We're building models that were really hard to build. And the fundamental value of their product is in the prediction. Customers appreciate that, and they contribute data back to the ecosystem. Those companies are still getting built. And, we haven't really seen a lot of the IPOs of AI first companies yet. They're still to come.
Yeah. For companies that are listening to this and wanting to be AI first companies themselves, two related questions. One is, what are obstacles that are holding them back, and how can they overcome them? And two, what's something they could do tomorrow to get started on the path to being AI first?
Yeah, look, I'm a pretty technical person, but I'll start with something totally non-technical. It's just using the right vocabulary. You've got to equip your team. You yourself have to equip yourself with the right vocabulary to understand and talk about the power of this stuff. To understand the sort of competitive advantage it actually gives you. People today are using phrases like data's the new oil. People today are using phrases like network effects when they talk about AI, but neither of those things actually describe what we're talking about here. This like real amazing runaway competitive advantage you can get from building this stuff. So just having the right vocabulary, I introduce a lot of that in the book, data learning effects, et cetera, et cetera. We don't have to go into that now. But having the right words so that you have the right conversations about what products you want to build, what data you want to collect, how you want to use it, what people you want to hire to work with it, et cetera, et cetera. That's the first thing. It's not a technical thing. It's sort of a more strategic or just smart thing to have when you're having these conversations. The second thing is just being very careful about how you allocate capital to collecting data. Collecting data to train these models can be really expensive really quickly. For example, if you just go and label a lot of data, it can be really expensive. Or if you go and buy a lot of data, it can be really expensive in certain areas. It can be cheap in other areas. If you have to build a product to go and collect a whole bunch of data, build some consumer product off to the side that people are going to use and generate a lot of data, like some new like network monitoring security app or a new mapping app or a new messaging app or whatever, because you want to actually collect something else about someone. That can be really expensive. So I think a lot of people just spend a lot of money collecting data that they ultimately won't use or isn't really going to help in terms of making their models better. So I think that's another thing. And then the third thing is trying to do too much yourself in terms of building models on day one. The stuff that you can get from Amazon and Google and whatnot now is so powerful. And in a lot of this sort of automated machine learning is very limited in a way, but also very useful just for the initial experiments when you're still in this sort of lean AI phase. And so I think there's a little bit of an overinvestment there early on. And then finally, to just state the obvious, it's just being really clear on the problem you're trying to solve, which is like what predictions are actually valuable to people. Like, I was sort of talking through my example before about, how much meat you've got left in the fridge at the end of the night at a restaurant. That's probably not something you can really move the needle on, so to speak. Like meat is just a perishable thing and it's sort of like pretty horrible to work with. So you're not really going to make much of a difference there. But if you can, for example, predict a trend ahead of time so that you don't buy too much inventory for your e-commerce site, you might get to the point where you don't have to do those crazy end of season discounts and just liquidate all of your stock for less than costs. That can probably move the needle. So just picking the right problem. Another aspect of picking the right problem is pick something that is intellectually honest, as in, AI is not going to be right all of the time. And so don't pick problems where getting it wrong is going to be really expensive. And this is true of a lot of problems in the healthcare space and the medical domain. Just don't pick problems where, it's a life or death decision. You can't rely on AI for that stuff. Pick problems where, if you get it right, awesome. And if you don't, well, it's okay. Like sales and marketing and managing cheaper inventory, stuff like that.
Totally. Before we close, we had one question from another question from the audience. So I want to bring Jason up to ask.
My name is Jason. I am the founder and CEO of Skill Magic. At Skill Magic, we're building AI-driven software to help you train your junior engineers in record time. And my question for Ash is, so another hot trend along with AI is product-led growth. Are you seeing anything interesting at the intersection of AI and product-led growth, especially at the top of funnel? And I'm basically talking about like AI obviously is going to drive your core product, your core business, but obviously customer acquisition is really important. So are you seeing any sort of effect on maybe the models or anything actually driving some sort of interesting, like either paid or organic acquisition channel?
Yes, a lot. I would say that there's still a bit of a problem here in that a lot of the data you have on your customers and from your marketing systems is sort of all over the place. You got lots of different systems going on. And so there's an opportunity here to build a platform, I think, that consolidates all of that marketing data that's relevant to product-led growth. So I think there's still a bit of a data problem that makes it hard for people to generate models that are very stable or very consistently help you understand your customers, send them the right message at the right time, et cetera, in product. So that's one thing. There's probably also a deployment problem here, which is it's not the case that there are that many good ways to deploy the message you want to deploy to a customer in your product. A lot of them are still hand-coded. So all I'm saying is like a lot of this stuff is still hand-coded. And if that was sorted, then yeah, we could just focus on the models. If all our data was in one place, if it was the case that once we developed like the right message to send to the customer at the right time, and we had a really good system for doing that to certain customer segments and whatnot, there's been some progress there and some good products out there, then we could just focus on the models. So I think it's hard to just focus on the models that enable really good product-led growth right now. That said, there's sort of some basic stuff out there that's really good. A lot of the existing platforms, like stuff built on top of Salesforce, on top of HubSpot and whatever, is good enough. It's good enough to go some of the way there. But the really advanced stuff is also going to be really product specific. So I guess this gets to the core of your question. I've seen a lot of companies recently trying to effectively deduce from customer support tickets, from usage patterns, from whatnot, what customers really want to do next and what features they'll pay for. And it's really hard to develop those models on a global basis because every product's so different. Modeling the behavior of a customer that's like buying a video game to buying a SaaS product, like buying a CRM, to buying something completely different, like your product, for example, they're all completely different customers with different behaviors and whatever else. And having like one global model that models all of their behavior in all of these products is basically, again, an intractable problem. So I think maybe what we'll see is better data management tools, better delivery tools, maybe some industry-specific product-led growth, AI-first companies, and then maybe some better tools to at least like automatically segment, distill some signals of like what customers want to do next or what features they want to use. So we might see something there, but I doubt we'll see just one company that lets any company do product-led growth.
Thanks, Jason.
Yeah, thank you.
Good question.
Maybe as a segue to our last question, and what newest trends in AI are biggest opportunities for businesses of all types right now that we haven't yet covered?
Yeah, honestly, just using it at all. Like we're still at the point where most people aren't doing all the really cool stuff. They're not really using the full power of it. And so what do I actually mean by that? For startup founders, I think the biggest opportunity is to build tools for data science and machine learning. Stuff like what Jason was talking about, like build tools that let others build good models. That's a huge opportunity. And then secondly, there's still so much opportunity in managing data. Like I hate to be sort of boring about it, but just helping people get their data in the one place, clean it up, label it, synthesize better data. There's so much opportunity there. And then also around understanding data. There are all these great books out there by people like, Edward Tufte, Nancy Duarte, and whatever else about visualizing and understanding data. Yet there are so few ways for people to be assisted in their presentation of data. So, building tools to help people basically make presentations, I think is a huge, huge opportunity. Make graphs, make charts, whatever else, that actually look at the distribution of data and go, you should use a pie chart. That's an overly simple example. but you should use this. You should present it this way. Tell your story this way. Like telling data stories is a way to communicate information that we're still so bad at, because, our brains don't work that way. Our brains don't work like a calculator. Our brains don't work like Excel. And so this is a way where AI can really help us. So it's a little bit meta, but I think there's a huge opportunity there.
Yeah, I think that's a great place to wrap. Ash, this has been a great conversation and episode. The book is AI First Company. Thanks so much, Ash, for coming on.
Thank you so much for having me.
Okay, thanks everybody. Thanks villagers. See everybody soon and take care. If you're an early stage entrepreneur, we'd love to hear from you. Check us out at villageglobal.vc.